Alright, these are the 9-4 notes. You'll need to make sure these are done for us on Monday. We'll go over them more in depth if you need, but you should be good to go here. So 9-4 notes, we're talking about graphing exponential and logarithmic functions. Okay, I believe you saw both of these in Algebra 2, so it shouldn't be a huge surprise for you. But today we're trying to investigate what the graphical connections between exponential and logarithmic functions are. So if you can tell me what the connection is by the end of the lesson, you would be good to go. Alright, so the parent function. Each positive real number base produces its own parent function. So in exponentials, you don't really have a true parent function, whereas in linears, it's definitely always y equals x, or in quadratics, it's always y equals x squared. Here, each of these are their own parent functions. A couple things to note here. Notice that this one that grows the slowest is 2 to the x. That arrow should be pointing to this one right here. Okay, 2 to the x, just to make sure that's clear. Now, if we were to type e into our calculator, that's like 2.71828. Notice that that's a bigger number, and it's growing faster. Then we have y equals 10 to the x, and notice it's growing fastest of all. So make sure you see that connection there. So these are all exponential functions. We refer to those as our banana graphs. Okay. Over here, we have our logarithm graphs, and similarly, there's not really a parent function because it depends on the base. Most often, you're going to be talking about your log base 10 graph. And notice that this would be log base 10, and it's growing the slowest, whereas log base e, or natural log, is growing faster. Okay? So let's chat really quickly about the transformations of the parent functions. If the negative is with the exponent, if your exponent is negative, this is going to reflect across y-axis. Okay, that's going to reflect across your y-axis. If the negative is out front, that is going to reflect across the x-axis. Okay. If you have something added or subtracted in your exponent, that's going to move it left or right. And just as with any transformation, if it's minus 3, it's going to be opposite of what we think. This moves right 3. From your traditional y equals 2 to the x. So we're using the parent function y equals 2 to the x for all of this. If it says plus 4, that's actually moving left 4. We have 2 to the x plus 2 added after. It's not affecting the exponent at all, just out to the front, out to the side. That is going to move your function up 2. And if we subtract, that's going to move it down 3. Notice how these are different, right? These both have a minus 3, but the placement matters. If it's in the exponent, it moves it left and right. If it's out here, added or subtracted after, it moves it up or down. If we multiply out front by a number, notice that this 3 is bigger than 1. That is where you're going to have a vertical stretch. Okay, and that's going to be a thinner graph. It's going to grow faster. Okay. You can think of that as being a thinner graph. Just like with quadratics, remember the bigger the number, the closer to the y-axis it got, or the skinnier it got. Same thing with that vertical stretch out front. Notice that this number right here is between 0 and 1. Okay, actually, strictly less than 1. Okay, so it's between 0 and 1. It's smaller than 1. This is going to be a vertical compression, where it's going to push it down and make it wider. Okay, it's the same over here. Everything is the same with logs of how it works. Right? If it's in parentheses with the x, just like it is over here, right? It's with the x here. It's with the x here. This is going to be a reflect across y-axis. If it's out front, just like over here, this is going to be reflect across x-axis, so that's a y. If it's inside the parentheses, it's moving it left or right, so this one is going to go right 1, left 1, or excuse me, left 5. Now this one is not in the parentheses, it's outside of the parentheses or away from the x, so this is going to move up 4, down 6. Here we have a 4 outside the function, out front, so just like over here, this would be a vertical stretch because that number is greater than 1. Here, 1/4 is between 0 and 1, so this is going to be a vertical compression. All right, so you will need to know all of those. So let's take a moment to do this next example. Describe the change from the parent graph, then graph the function. We have 2e to the x minus 4 plus 1. Okay, let's just go kind of systematically. What would this 2 do? It is out front, so that is going to be a vertical stretch. Okay, e to the x minus 4, since that minus 4 is with the x, this is going to move the whole function right 4. Then this guy right here, the plus 1 at the very end, that's going to move it up 1. Okay, so here I like to pick some negative numbers, I like to pick some positive numbers. You can put this into your calculator to kind of figure out what those values are. So let's show you how to do that in the calculator. So go to y equals. And put that in. So I'm typing 2. Remember to get e to the x with an exponent, do second ln, x minus 4. Make sure to hit the right arrow so that it pops down, and then do the plus 1. Alright, so I'm going to choose just a few values. I like to pick a couple of negative ones. Always include 0 to see what's happening there, and a few positive ones. Okay, so after I've typed that in, I can go to second graph, and at negative 2, I see that that's 1 point, essentially, it's about 1. I'm just going to say about 1. Okay, at negative 1, it's about 1. 0, it's about 1. So not a lot of interesting stuff happening here. 1, it's about 1. Actually, let's go ahead and bump this up a little bit. I'm going to go ahead and change this to 3 because that's when stuff starts getting interesting. That's about 1.7. And then if I choose 4, okay, I'm just trying to pick nice numbers on my calculator. 4 is 3. Okay, so those are the numbers I ended up picking. You might change them once you get in there and look at it. So negative 2, that's about 1. Negative 1 is about 1. 0, actually those are a little bit more than 1 here. 1, 2, 3, 1.7-ish. 1, 2, 3, 4, 1, 2, 3. Okay, I'm actually going to just kind of look at my table to get a few more. What's happening as we go really far out? Look here, when we zoom out far enough, it's saying, okay, look, it's essentially just 1. So what is it called when we get really close to a line, but we don't actually touch it? Right, we had these with hyperbolas. That's an asymptote. It's going to get really close to that line, but not touch it. The line y equals 1 is going to be an asymptote here, okay? Now let's go in the other direction, and let's just see as we go out. We did x equals 4. Yeah, but then it starts getting crazy here. So like 5 and 6.4. 1, 2, 3, 4, 5. 6 and a little bit. 7 is already way off the graph. So you can tell that it really starts blowing up here. Okay? So just use your table to get enough points for it to make sense. since we have that function in there, we can hit zoom 6 just to kind of see. Notice that is never going below the line y equals 1. So that's what we would say our asymptote is. Now looking at this is where that vertical asymptote or horizontal asymptote of 1 comes from. Normally with an exponential function, it's approaching that line y equals 0. But since we moved the whole function up, we also moved up the asymptote. So here, domain, we're going to go forever in the x direction. We're going to keep going forever in the negative x direction and positive x direction, so that's all real numbers. Our range, what's the lowest that this is going to be? The lowest it's going to be is ever close to 1, but it's going to go forever. So our range is y is greater than 1, not equal to, because it'll never touch that line. Another way you can write that is 1 to infinity. Okay, either way, I will accept either way. And then the asymptote is the horizontal line y equals 1. Don't put a number here. It needs to be an equation. Okay? It needs to be an equation. All right, let's do the log. Let's do the log version. Okay. So we want to describe the changes here. This 4/5 right here, that value is less than 1, between 0 and 1, so that is going to be a vertical compression. Plus 3 inside the function, the plus 3 means that it's going to move left 3. And the minus 2 means that it's going to move down 2. All right, once again, I'm going to put this into my calculator. So clear that out. I'll fill y equals 1 to get a fraction, 4 over 5. Hit the right arrow, so I come over here. Hit the natural log, parentheses, x plus 3, close parenthesis, and minus 2. Make sure you don't put negative 2 there, you'll get something wrong. It's a minus 2. So let's go to my graph. All right. Ooh, errors. What does that mean? Okay, error means that it will never be lower than that value. So it looks like our first actual point here is -2, -2. That's a good point. Okay, then let's kind of see what's happening here. 0 is about -1. Okay, let's see if we have some other nice points. Okay, so it starts getting really small there. So let's see, I might pick, ooh, there's a 0.5, so like 3, -0.5. Okay, let's keep going. It's getting very small there. Very, very small. It's looking like it's getting pretty close to 0, if you ask me. Let's see. I would say at about 9, you're at about 0. Would that be fair? Right, you're almost at 0. Okay, so let's see here. Graphing this, looks like we have -2, -2, 0 about -1, 1, 2, 3, that's about -0.5, and 9 is about 0, not quite. Okay, but what's happening over here at 3? Remember, you can always go in here and look. It looks like it's going to get very close to this line, but not cross. Now, normally, we'd have a vertical asymptote at the line x equals 0. But because we moved this whole thing left 3, we're going to have a vertical asymptote at the line x equals 3. So we're going to get very close there, but never touch. So domain, we're always going to be to the right of that line. So domain is x greater than -3. You can also put open parenthesis -3 to infinity. We're going to go forever down. Forever. Are we going to go forever up? I don't think so. Yeah, we'll eventually. right? We can keep going. Let's see, if we were to go back to our table and zoom out far enough, it keeps getting bigger and bigger and bigger and bigger and bigger. It'll take us a long time, but the line x equals y equals 0 is not an asymptote here. So it looks like we'll be going from negative infinity, because it's going to keep going down, from negative infinity to positive infinity. So that would be all real numbers. And then your asymptote, we have a vertical asymptote at negative 3. Okay, so there's that. And that is your notes for today. So please complete your 9-4 homework, and we'll meet back at class next time.